So, alright, what is happening here is that I am trying to solve this, like prove this one, that how this power really works. Um, like this has the log of base p, log of x and of base p is equals to the power into log x of base p. Okay, so let's check it out. I've asked AI to prove this power rule. So the question number one has does it. Okay, so log of x to the power n of base p is y. That means that b to the power y is x to the power n. Yep, I know it. Yep, I've done this. Like this base to the power n is equals to base to the power 2. That is 6. Okay, now tell to the exponent exponent y that makes p raised to the power y. Yep, I agree 100%. Now how can I express x to the power n using a logarithmic x? Okay, so since how can we express x to the power n? X to the power n using the logarithmic of x. That means of log x. Since what? Since p raised to the power log px from the inverse property raising both sides and gives this. Question number 3. I do not understand this part. Alright, now using the exponent root, what is b raised? Okay, so exponential rule says this, and now b raised to the power x is this, and now x raised to the power this is this. What must be y then? Y. So answer is by is equals to this. That means y is equals to n. Oh shit. So okay. So first understand this inverse rule. Growth of inverse rule. Shut up. Let's prove the inverse rule. Basically log of b raised to the power y of base p is equals to y and b raised to the power log p of x is equals to y is equals to x and log b raised to the power y of base p is equals to y. What? Okay, in simple way using the question to write process will assume p is greater than 0 and p is not equals to 1 and x is greater than 0 for the logarithmic to be defined. Proof of inverse property. Okay, now part 1 is log of p raised to the power y on base p is equals to y. Alright, now first question arises is what does log p is equals to zg means. Okay, so basically that means that p raised to the power something is equals to p raised to the power y. Yep, and this gives exponent z, that is. Question 2 is since the base are same, then exponent should be same. That's why g is equals to y. Therefore this log b is this answer z is equals to y. That's why I'm missing something. I'm missing something. Therefore, the log of p raised to the power y p is equals to y. I didn't understand this. That means something on this thing, and that something is y. That's it. That's it. That's it. That's it. Okay. Now the part two is this. Okay, now it's time to write this one. Okay. So that we get a clear, concise understanding about this. Alright, so start. So log base p, that means we keep something on the power, let's say n is equals to p raised to the power y. That's it. And that is the power. What would be the answer of this log? That means this answer is y. Is it? You're getting my point, man? You're getting a point? Okay. Okay, I got it. 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 I got it very clearly. I got it very clearly. Now let's understand this one, the bigger picture. Alright. So what is happening here is that p raised to the power log p of x. P raised to the power log p of x. So there is no power in the main function. Alright. So that's why what would happen here is p raised to the power log x on base p. What can I do here? That means p raised to the power something is equals to x for the power, right, for the power. So what is happening here? What does log p? This means okay, yep, some power. The power is w, okay. This means pw is equals to what? Okay, that means b raised to the power something is x. So this something, let's say w. Okay, b raised to the power something is equals to x. I mean w. B raised to the power w is equals to x. And w is what? It's the answer of this log on base b on this x. Okay, is this w? Okay, that means b raised to the power w is equals to x. That's it. The power is w. Alright, power is w. Okay, this is the function in here. Okay, but the answer is this. Okay, so basically what's happening in here, that B has a power, all right, power, and then this power is the log, all right, this power is log, uh, B has a power, B has a power, and then this power means log of B of X. Yep, that means what will the answer is, what is the power of B, what is the power of B that returns the value of X, correct, that returns the value of X. Yep. So basically this thing would be the answer, that means W, right? So the log of this would be the W answer. So that means it evaluates to W, and then we know that B raised to the power W is X. That's why we are getting this X. All right, okay, okay, cool. Now let's understand this rule once again. Mhm. This rule once again. So what is it saying? How do we copy this? No. Okay. All right. So what it is saying is log of base B. Log of base B is x raised to the power n. X raised to the power n. Log of base B of x raised to the power n. So can we express this B? Okay. So that means, what does that mean? That, oh wait, that the answer would be B has something in the power that is equals to x to the power n. Correct. X to the power n. That's it. That's it. That's it. Sign this. How can we express x to the power n using logarithmic of x? Okay. So we just knew that x to the power n, correct, x to the power n. Okay. So the x, what was the x there? Okay, what was the x there? So if we do log of base x into what, log of base x, sorry. Log of base b, what was the inverse rule, man? No, b raised to the power, b raised to the power log. Okay, the rule was, the rule was, oh damn, b raised to the power log b raised to the power log bx. This is it. This is it. This is it. That means W The answer will be W here. So W is what? B B no. W is what? Log B of X. Correct. 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 And this has the power of N. Correct. 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 Very good now. That means हाँ बना हाँ So basically we learned in our junior classes that in mathematics that we have root for something like 64. Correct. But when we are grown up, what has happened? We can write this here that log base 64. Correct? Let's ask AI. That means, can we write all of the square root in log base 2? And we are correct. It is this, okay. For example, this root 4, the log 4, because 2, the 2. Yes, we are correct about it. Okay, so from today, that what is that means? That log of anything, alright, log of anything, like here, in here, what is this? What are this? Chain, base, corn, log this, power rule, this thing, correct. This thing right here, that basically, what does that happen, man? Yep. So this thing basically means that this one, x to the power n, has base p. That's it. 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 Is equals to n into root x base p. That's it. That is it. That is it. That is it. That is it. Yep. That is it. So basically we don't spell out root every time. We just know it's log. It's log. Alright, it's log. It's log. So basically we do not spell root as it grows complex. We call it log. It is this. Log of base p x to the power n is equals to that equals to root of xm root 3. Okay, cube root. What do you call it? What do you exactly call it, this one? Oh, damn. No, they are different. Is it? It means the exponent y says that. Just what does this mean? This means the bth root of x to the power 1, because this is a number. So it says that z to the power p is equals to this z to the power b. But in log, okay, so basically let's say log of 64, okay, base is 2, that is what, 6, correct. Oh shit. But this is 8, this is 8, correct, this is 8, this is 8. Yep. They are not similar. We are doing this that how many times this is multiplied by itself, correct. How many times this multiplied by itself. Okay, okay, okay. But in here, we are directly finding the number of this. That what is the number that multiply by itself 2 times, and this will come as 64. Okay, so I'm wrong. I'm definitely wrong. I'm definitely wrong. Okay, so we should ask like this, that if we keep it 8, yep, 8, 8, and this 8, yep, so 8. Let's say if we had 125, okay, if we had 125, if we had 125, let's see, 135, but in 125 is this and 3, base 2, okay. So if we do log of base 8, log of base 8, correct, log of base 8. Put the log of base 8, then it would be the answer. Correct. Alright, 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 alright. Not a biggie, not a biggie, not a biggie, not a biggie. Okay, 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 I got it, 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 I got this one, I got this one too. Log square, yep, I got this one too, I got this one also, and then I got this one also, and then this is the inverse of this, right? Is it e raised to the power? Yep, this is the inverse, this is the inverse. Yep, 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 yep. Isn't it? Inverse. Come on, come on. B log P, P, B log P, P raised to the power log XP. That means no, this is not it. It is not it, but it's kind of this, kind of this. That means we do a log of this. It means that's it. Geometric series. Arithmetic series, geometric series. It's exponential sum. Harmonic series is this other. Okay, okay, okay. Now, master theorem and divide and conquer. Okay, so it's a quick sort. We have learned this already. That divide and conquer with algorithm. Okay. Now, in all divide and conquer algorithm, we find that divide into sub problems, and each of these is some part of the original problem. Show what becomes the final answer. And as the example, if you consider merge sort, okay, for detail paper sorting chapter, it operates on two sub problems, each of which is half of the site original. Yep, 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 yep. And then use big and additional work for merging, and this gives a running time equation. Hello. Yep, my mic is working, but I don't know. Sometimes it doesn't take the audio. All right, now as in okay, so it operates on two sub problems, and each of these of half of size of the original, and then we use big O and additional work merging, and this gives a running time of equation of 2t into n by 2 plus big O n. The following theorem can be used to determine the running time of divide and conquer algorithm for a given program algorithm. And first we try to find the recurrence relation of the problem. If the occurrence is of the below form, we directly give the answer without failing fully solving it. Okay. So if the recurrence of the form Kn is AT, uh, AT, oh damn, it's getting harder. It's getting harder. Oh my god, there's a lot of things. It's a lot of things. Alright. Problems divide and conquer master theorem. So, oh my god. Runtime of Tn, runtime of n is 3t n by 2 plus n square. The runtime equal to 3t n by 2 plus n square, that is runtime of O n square master phase 3. I don't know what's going